We're here to talk about shopping and what Glance AI is supposed to do that, right? Quick question, how many of you have Glance AI installed? Have you seen? Okay. How many non-InMobians? Okay, good number. Okay, all right. So, Stan, if you can bring up the screen. All right. Whoever has used would know what I'm trying to do. So we'll let that cook. All right, so shopping. Shopping today is a bit of a mess, right? At least for me. So I'm here to tell you two things. One, story of how I do my shopping. And second is about how Glance AI is supposed to help for it. But I'll also tell you how time can change the way we shop. So shopping, there is intentional shopping. These are stuff where I need it, I buy it, I come back, and I don't know if I'm happy with it, but I need it. Then there is the inspirational shopping. This is like, we keep scrolling, there is an ad comes in, and you scroll, 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 you buy it if you like it. Most of the time it ends up in a wish list, right? So we're going to talk about inspirational shopping and how what is my story of it. So there is this set of clothes which I regularly wear, and I really like, wearing them. I want to shop for them, and it's not intentional, right? I don't go sit on a day, oh, I don't have clothes for next week, I do this. I'm like, scroll, and I find a bunch of stuff. Three things can happen. Either I like it, or I'll buy it, or everything looks good, I don't end up buying anything, and I just waste my time. Third thing is I'll just put it in a wish list, and I forget about it. Now, these are the clothes that I like to wear, and there is a situation where situation demands that I have to wear something. So let's take an example of a vacation. So recently, we took a vacation, me and my wife, to Bali, right? So there was a precursor to this. What vacation is so good, but the work that happens behind is so painful that before 40 days, 30 days, she started saying, okay, buy your clothes, do that, get some floral shirt, all of that, and I just kept postponing. I'm sure a lot of people have done this. Now it is 2 weeks. Now she's took it upon herself to say, okay, I'm going to order a bunch of clothes for you, and you try it out. I was like, okay. Now they kept coming, I kept trying, I don't like them, I'm stuck in a situation where I can't say no, but I have to buy something. So this inspirational shopping that was supposed to be, because of time, got into a intentional shopping that I had to buy. Only if I had a way to get what I want, and ease of access, plus how I have this question, what would it look on me, right? So these questions, if I had answered, then I would have bought something. Now, this is me talking about my wife. She's a different kind of animal when it comes to shopping, right? So she starts with Pinterest, looks at inspirational images that she wants to buy from, goes to Instagram. There is a bunch of influencers that she'll look at, what to wear, where, which location, all of that, puts it on a mood board, then literally writes down a document like a PRD. We are all so used to that. So then the document is like literally this day, that location, this day, that. So this is it's a fully researched document that she gets into before shopping happens, right? Then she goes on to hunt that cloth, the perfect outfit she's chasing. Now, I'm very simple. I like something, I try it on, I buy it. My wife is different. She does a full research, and then she buys it. So there is different spectrum of people who do shopping, and it's very different. And we don't want to leave out anybody, and both are users who wants to buy clothes. Both are people who have different needs at different times, and there is a whole range of spectrum in between. So how does Glance AI help me do this, right? So we'll take a look at the app, which, okay. Basically, as soon as I gave a selfie, a bunch of things happened in the background, which I'm not going to get into. And it started generating some avatars of me. These are looks, what we call them as looks, right? So it has put up a look of me walking on a road, and then there is this look of me standing somewhere. You get the idea. It generated looks of diverse positions, diverse locations of me doing a bunch of things, wearing different outfits in different settings. For example, this one, if I ever go to New York, it is telling me that these are New York appropriate clothes. These are some things that I have to wear to belong or to be appropriate in these locations. Some things I would have never discovered if I had to do my shopping myself. So for me as a simple person who is in Bangalore and I want to just get by what I want, I would have probably chosen something very simple, right? Something very simple like a t-shirt, this one. So while it gets me to this stage where this simple cloth, I can just try it on, and then I can buy it if I like it. This is solving a problem that I have. How does it solve for someone like my wife, who she really has to nail down the problem, right? So for someone who has to really nail down that outfit, let's say this is a cloth that I will probably, okay, this is still decent enough. I will not probably wear this. But let's say I want to try something of this, then I'm going to look at similar looks. What we discovered is shopping happens a lot in the similar section rather than the product that you're advertising, right? So there is a feed which is basically showing me different kinds of outlooks in the similar one that I clicked on. Or I can go really deep. I can keep going deeper, deeper, until I find that exact similar outfit that I have in mind. In my wife's case, it's going to be that perfect picture that she wants to see, she wants to take because she saw it on some Instagram video, right? So it really helps her, who is like research-oriented shopper, and it is helping me, who's a simple shopper. Now, there are two things that we started with, intentional and inspirational. Intentional is, for me, I want clothes, and I have this simple t-shirt that I want, and I can buy it. But it is also showing me some things that are beyond the boundary of what I as a user would shop for, and it is letting me know that, okay, here is a cloth which would equally look good on you, and then I can try that. So it is expanding the choices of my wardrobe without me doing a lot of work, and this helps me in ways that it would not have possible like before this, right? Now, I don't know about you guys, but if we had this app, it would have been a lot helpful to, in the trip that we took. But here we are, and this is so helpful. Now, going back, how does the convenience of saying that, okay, now you have this, how does it appear on me? So let's say we're going to do a bunch of try-ons that I think will look good on me. Let's take this one. Okay. Great. Okay. So what I just did is, I just saw a picture, I liked it, the outfit, and I'm going to say that, okay, how do I look on this? That question that I had in the beginning, how would this even look on me, is going to get answered in very soon while we go through the rest of the feed. So what are these? The feed is basically comprised of a bunch of things that the Reco has thought and has put a bunch of images that it thinks based on my past interactions, based on the color that would look good on me, the brand preferences that I have, the interactions that I've done in the in the system. So it has put together this entire feed specifically for me. They are not going to be same for you and me, right? Two different people. So there is a bunch of, as you can see, there is good amount of collections, as we call it, being shown here. And I mean, I can like something, so recommendation will come up and say next time that it starts recommending more of that. Okay, so now generations have happened, the looks that I just asked you to try on. Okay, this looks decent enough. This one also. Okay, this looks decent. Now let's see how easy it is to buy. I'm going to click on this, and then maybe see the images, right? What size it is, L. Then I'm click on buy now. Boom, I am in the shopping world now. I know what to do. It's familiar territory, right? So that's the convenience that app is solving for me and my wife, where we are two different shoppers. So that's the app part. And I'm going to say that this is the demo that I want to do for the app. One other thing is that the feed that you saw, which my job was to get you guys to install this app and try this out a lot, right? So when you see this, it's going to look different for you, and I'm hoping all of you will like it. So and keep the feedback coming through the day and in the Discord that we'll have later. So would love to hear. And calling Akshat and Satyan to talk about the AI in the Glance AI. Clicker is there.
Okay, cool. Okay. Hi, guys. Thank you, Chetan, for this lovely demo. So I am here to talk about one of the problem statements that we're trying to solve in Glance. So the problem statement that I'll be talking about is virtual try-on, right? Virtual try-on. So what does it even mean, right? So assume that I go to a physical store, right? I'm currently wearing a black shirt, right? So black color, by the way, suits me. Let's say I try to find some floral shirts, right? I would then go to the changing room, then try the shirt on, right? But let's say if I like 10 or 15 other garments, it would be a hassle, right? Just go to the changing room, try it again and again and again. So what is the other alternative, right? So virtual try-on exactly tries to solve this. So you have the user, let's say me, and let's say the garment is a floral shirt. I basically want to place that particular garment on top of me to basically get the feel and the vibe of the shirt. Cool. Now that we know what the problem statement is, right? Why is it hard, right? So it is hard because of, again, there are three main things. The first one is accuracy, right? So if you can see my shirt, it's a black shirt, right? It would be pretty easy to just copy and paste it, right? But let's say for floral shirts, for shirts with patterns, textures, etc., right? So it becomes very challenging to just overlay that garment on me. So accuracy is very paramount in this sort of a solution. The second major hardness of this problem statement is body types, right? So I do not consider myself as athletic. I consider myself as somewhat of a plus size, right? So my expectation from the solution would be that if I were to do a virtual try-on on myself, I would get a similar sort of a body type, right? So tackling this sort of a issue is very important in this case. The third one is more towards a technical issue where technical challenge, where the data sets and models which are available in the open source world, right? Those are pretty much non-commercial. You have a lot of clauses to use them. So we basically thought that if we were to do this sort of a virtual try-on, and this basically would drive a lot of transactions, right? So why not build an in-house solution? Now coming to synthetic data sets, right? Before even talking about it, I basically want to talk about why do we even need this, right? So focusing on the word diversity, right? So as you guys know, diversity could mean a lot of things. It could be different skin colors, different ethnicities, etc., right? But for the specific use case of virtual try-on, it basically is more about the body type. So the way a traditional virtual try-on model works is you have a user, you have a garment, then you have some sort of masking or maskless techniques where you basically create a mask around the shirt, and you basically try to train a model just to denoise that particular image, right? So that's where you basically want to get the whole body type spectrum, starting from like thin people, then to plus size, right? So that was our major motivation in trying to create these sort of data sets, right? So the way we do it is pretty standard. We basically, what we do is we use state-of-the-art stable diffusion models to generate a garment and a person, right? And this is, and then we basically do auto cropping and then resize to a particular dimension, and then we basically feed it to the model, right? Now, synthetic data sets, okay. Now, synthetic data set I've talked about tries to solve for body type. That is the major motivation, right? But it has its other positive things as well. So, like if you go through any open source data sets available for virtual try-on, those are basically very professional data sets in the sense that you have a garment, a folded garment, and a person standing straight, right? So it makes this virtual train problem a bit easier for that data set. But if we were to if we were to run this in real life, you basically have a lot of caveats to it, right? You have different poses. For example, let's say I'm sitting in a cafe and I want to do a virtual try on myself at that point. So it becomes very challenging for a standard standing pose, right? So basically, what this synthetic data set also solves for, apart from body types, is user poses, face structure, skin tones, hair colors, etc. Now that we have a synthetic data set, we are basically in full control of what we want to generate, how much focus we want to give to a specific sort of a garment, etc. Cool, geeky stuff. So here I would want to talk about the architecture of how we're trying to solve this, right? So I'll basically spend a few minutes on this particular slide. So basically I'll start about the inputs, right? The inputs for this particular model are 4. You basically have a person, a garment, then there's something called a mask, which essentially tells the model that, okay, change only those particular pixels and don't change the backgrounds, right? And then you have something called prompts, which essentially says that this is a particular cloth, make it wear to a particular person, right? So the way this particular architecture, the particular architecture we have worked on, basically tries to combine both person and garment images, tries to concatenate them, and then pass it to a VAE encoder. Now, VAE encoder. We basically use this VAE encoder to convert the images into a latent representation, right? So assuming that if we have not done this, so as you know that images are very high resolution images, right? You have 2K, 4K images. If you were to process them at a pixel level, it becomes very challenging to process them, right? So the way these VAE architectures work is, you basically have an image, and then you basically try to convert them into a latent representation, and then you can do all sort of post-processing or manipulation on top of it, right? So coming back to the architecture, we started with a person, we have a garment, we basically try to concatenate them, do some sort of pre-processing, image normalizations, etc., and then pass it to a VAE encoder. This particular VAE encoder, what it does is, it tries to downscale by 16x. So the resolution that you see on the concatenated part, right, 768 cross 2048, which came from concatenating two 768 cross 1024 images, those are basically downscaled by 16. So it's 768 by 16 and 2048 by 16. And VAE, on the other hand, tries to add 16 more channels. So essentially, what you're trying to do is, you're trying to convert the 768 cross 2048 into a latent representation, on which you'll do the next part of processing, right? So this is, we talked about person and garment. Now talking about the mask part. So remember, we need this mask information because we want to say to the model that only change those particular pixels, don't change the rest, right? So masking also has its own different processes. So there's something called mask processor, which essentially what it does is, it tries to normalize the images, do some sort of pre-processing steps, and then convert it back to 6144 cross 64, right? So in the pre-processing block, you can see that there are two basically tensors with 6144 cross 64. First one is the person and the garment, the information from the images, and the second one is more on the mask. So now what we do is, again, we concatenate both of these latents and then pass it to the flux transformer. So the first input to the flux transformer is the combined information of the person, the garment, and the mask, right? Coming to the last input, which is the prompt, right? Prompt, as in you would say that this is a particular shirt, make this wear on me, and you describe the shirt, the person, etc. So this prompt basically passes through two models. You have clip and then T5. We use frozen weights for these, and then you basically convert them into a text embedding. Now, the whole magic is being done by this flux transformer, right? The inputs to the flux transformer are the concatenated latents from the images and the mask, the text embedding, and the time step embedding, which essentially tells what is the time step for denoising, right? The main purpose of this flux transformer is to denoise, right? So if I tell you intuitively, what basically is happening is, you're basically trying to inject noise to a particular latent, and then trying to denoise it basis the prompts and the masks. So at inference time, what will happen is, you basically give a human image, the garment, and the mask, and when it tries to denoise the mask, it will try to condition based on the prompt and the model learned, right? So specifically in the flux transformer, we have two main transformer blocks. First is the dual transformer block, which takes into account image and text. The second is single transformer block. Now, going a little bit deeper on those blocks, right? So the first block we'll discuss is more about a dual transformer block. So as I said, that it takes into account image input and text input. It does some sort of self-attention and cross-attention, and then you have a couple of feed-forward layers to basically give the similar sort of outputs. The other is basically a single transformer block, which takes into account only text, do parallel computations on self-attention and the feed-forward neural network, and then concatenate, and then get the output. Now, I want you to focus on two things, right? First of all, the colors. The green color that you see are basically the trainable layers that we have tried to train on. The blue ones are the ones which are frozen, right? So there is a particular reason for it. So attention layers in general carry more significance and dependence to the input as compared to feed-forward networks, and they have less number of parameters. So this is how we basically try to experiment on training various layers. We try to train both of them. We try to train only the feed-forward. And the best place what we got was to just train the attention layers. So yeah, this is all about the architecture. Now, we have a trained model, right? Recap, we had 4 inputs, right? We had human, we have garment, we have the mask, and the prompt. Now, once we have this particular model, we basically do a lot of like inferencing optimizations and inferencing techniques to further improve the accuracy of the images. One of the optimizations is basically garment masking, right? So if you look at the first image is the input human image. The second is the garment image. So garment image can come in 2 forms. You can basically have a person wearing that, or basically a folded cloth, right? If I were to just use the model to just get the inferencing, you would get the output, the middle image. But if you focus on the shoulders, right, it has become pretty hunched because in the garment image, you have a model which has a little bit of hunched shoulders. So the way that we basically try to tackle this problem is basically remove all the skin from the garment images and then try to feed it to the model. So this way, the model only has a cue from the body type of the reference image, not the body type of the garment image, right? Then, again, a very cool thing. So as of now, we were only talking about VTON, right? But VTON in conjunction with prompts can actually change a lot of things, right? So if you look at this image, we now also have a capability to change poses, change a lot of accessories, etc. So it's not just about a virtual try-on now. It's about the actual aesthetics of an image, coming from poses, coming from accessories, etc. So the way we basically train these models, we basically have this prompt which can actually condition the final output of the image, right? So on the left, if you see, the person can hold hands from the back. The person can actually wear accessories, coats, etc. The other inference optimizations, what we did is something called object attention, right? Recap, we had 4 inputs, right? We had human, we had mask, we had garment, and then we had the prompt. The masking applies to the whole body part where the cloth is, right? But if you look at this image, the mask would also actually try to cover the cup, right? So if I tell the model to denoise it again with the garment of the newer garment, what would happen is the glass would be gone, right? Because the model will now try to reimagine everything, right? So the other, one of the ways that we try to solve this problem was basically try to subtract this particular mask from the input mask. Now, mask tells the model that only change those pixels. If we were to remove this particular mask, remove this particular cup from this mask, the model will not change that. And that's how we are able to retain a particular object. Cool. I'll take a breather. But in that time, view the outputs. So these outputs are triplets, where the first you have the user image, the middle one is the garment, and the last one is the object wearing them, right? I want you guys to focus on the rightmost image of the first row, right? The girl who's sitting on the horse, right? So we are actually able to retain the horse, everything, and we are actually able to put the cloth in such a way that it looks natural, right? It's not like a cut and paste solution, right? So this basically tells us our solution actually works for a lot of poses, a lot of backgrounds, a lot of objects, etc. Cool. I promise. Last slide. Cool. So this particular slide talks about our particular metrics. So we basically tried to calculate a lot of industrial level metrics, and then we tried to compare with some open source models. So we are pretty good in terms of like FID, SSIM, and CLIP. Also, this particular solution is in production, and our overall acceptance rate is close to like 85%. Cool. That's all from my side. I'll pass my baton to Satyan, who will be talking about the Reco side of things. Thank you. Fine.
Can you guys hear me? OK. So you saw the product from Chetan, and you heard about the VTON technology, which is built in-house to power Glance AI. Now, let me touch base about how we do personalization differently for Glance AI. So you've heard enough about how Glance AI is a more inspiration-out application rather than an intent-out application. So that differs from what Goda spoke about earlier in Swiggy, where they're trying to drive intent and understand the intent of the user and try to model that, right? So for Glance AI, what does inspiration mean, right? When you saw the feed presents a lot of looks, collections, avatars to you to imagine yourself in those avatars and then to do a transaction, right? So how does an inspiration-driven application differ from an intent-driven application, right? It's more exploratory. You're trying to show some cool stuff to the user. You are trying to drive discovery, aspiration, delight, and so on. The signals that you look at are more implicit in nature, right? What does that mean? That means you're looking at scrolls, you're looking at likes, content consumption, whether the user is doing try-ons, whether the user is sharing that image, and so on, right? And the output that we show to the user is more inspiration outfits, collections, and looks. If you look at our design of how we structured the recommendation, it's very typical to how you would do it for any e-commerce platform. At the bottom, you have the ingestion layer. We have data coming in from diverse data sets, such as Glance TV, Glance AI application, the lock screen. We have data from our partners, InMobi, what ads were served to the user, what ads did they click on, what is their brand influence, and so on. We also have data coming in from our D2C partners, and we also have the catalog coming in from our D2C partners, right? We combine all this information, and we have our in-house identity graph built in InMobi. We use that to create one unified view of the data. This data is then used to create our intelligence layer. So that's the third layer that you see on the screen. This is a shared intelligence, as we call it. Basically, it's user embeddings, user profiles, product look embeddings, and so on, which is then used to power our experience layer. The experience layer is the most important layer. How do we surface all of this as a feed, as collections, as similar products, complementary products to the user to drive inspiration? Although our platform appears very similar to a commerce platform, the recommendations are very different, right? Let me talk a bit more about that. Like I mentioned earlier, the goal is to drive discovery, aspiration, and exploration. The signals are very implicit in nature. So the features that we use are also very different, right? The modeling that we do are very different. Instead of looking at the user's affinity towards a product, what we are trying to understand is what does the image represent? What is the background? What is the context? What is the pose? And so on. We use different kinds of multimodal models out there to actually drive those, to drive diversity and novelty for the user, right? Let me give you an example of a model that we've developed. So this is a model which powers one of our important widgets at the top, which is today's drops. So here, we modified a two-tower architecture. On the left, you have the user-related features, and on the right, you have a look-related or the avatar-related features. So the user-related features are features such as, at the bottom, you see user preferences, which is like similar to a user profile. You also have features like all-time interactions that the user has done in the application. And then you have the recent interactions, which capture the context that the user is sitting in. We have different kinds of encoders, which try, because of the kind of nature that, because of the nature of the data that we have. which creates separate embeddings, and then we fuse these 3 embeddings, user embeddings, using attention networks to create one unified user embedding. On the right side, we do something similar with the look. A look is a visual representation which Chetan showed in the demo. And then there we are trying to understand the context, background, and so on. We use different models to encode. And then in the end, we are trying to predict if a user will get inspired or will do a positive interaction with that particular look. The results of that are pretty decent. We've deployed the model in production, and we see the increase in various product metrics, which are important to us, especially around the inspiration and engagement route, such as the looks seen, try-ons done, likes per user, and so on. So a bunch of these metrics show an uptick, essentially. OK, so that's it from me. I will then show the screen and then request you guys to please install the app and provide feedback to us either via the application itself or via the Discord channel. Yeah, thank you.